Hello students, so I hope you all are fine out there. We are doing exercise 21 A prove trigonometrical identities, isn't it? So we have completed till question number 42 in our previous videos. Now we'll start from question number 43 onward. Okay, so let's begin. So this is question number 43. We have 1 minus cos square A upon 1 plus sin A in the left hand side, and we are asked to prove this equals to sin A. So let's do this. 1 minus cos square A upon 1 plus sin A. This is what we have in the left hand side, isn't it? So let's take the LCM of 1 plus sin A and 1. We have 1 in the denominator of 1, isn't it? So let's take the LCM of these two numbers. The LCM will be 1 plus sin A. So 1 plus sin A into 1 is 1 plus sin A, isn't it? This minus sign comes here. 1 into cos square A is cos square A. Now this 1 means sin square A plus cos square A, isn't it? 1 can be written as sin square A plus cos square A. So sin square A plus cos square A. Are you getting me? Sin square A plus cos square A means 1. So instead of 1, I am writing sin square A plus cos square A. So this plus sin A comes here as it is. Plus sin A and minus cos square A. Minus cos square A. Okay. So in the denominator we have 1 plus sin A. 1 plus sin A. Now this plus cos square A and this minus cos square A can be cancelled. So let's take the common out from this two. Okay, here we have sin A and here we have sin square A. So sin A is taken common. So within the bracket remains sin square A. Here sin square A. So we must write sin A, isn't it? Because sin A into sin A gives sin square A. Plus this sin A is taken common. So sin A into 1. Sin A into 1 gives sin A. Okay. So in the denominator we have 1 plus sin A, isn't it? So either you write 2 plus 1 or 1 plus 2, both of them gives the same result, that is 3, isn't it? 2 plus 1 and 1 plus 2 is the same thing. So therefore sin A plus 1 and 1 plus sin A, same thing. So we can cancel this 2. This gives us sin A. Hence proved equals to RHS, isn't it? I hope you got this. Now let's move on to the next question. Okay, now let's do next question. Question number 44. Here in the left hand side we have 1 upon sin A plus cos A plus 1 upon sin A minus cos A, and we are asked to prove this equals to 2 sin A upon 1 minus 2 cos square A. And this question has been asked in the ICSE examination 2002. Okay, so let's do this. In the left hand side we have LHS equals to 1 upon sin A plus cos A, isn't it? Plus again we have 1 upon sin A minus cos A. So what do? We take the LCM of the denominators. Okay, so these two are totally different numbers. That means we need to multiply them. Sin A plus cos A into sin A minus cos A. So this is the LCM. Now sin A plus cos A into sin A minus cos A gives this. So this into 1. That means sin A minus cos A plus sin A minus cos A into sin A plus cos A gives this whole thing. So sin A plus cos A into 1. Sin A plus cos A, isn't it? So this minus cos A and this plus cos A can be cancelled. So sin A plus sin A is 2 sin A in the numerator, isn't it? So we have 2 sin A in the right hand side. So in the denominator we have sin A plus cos A into sin A minus cos A. This can be assumed as A plus B into A minus B, isn't it? So A plus B into A minus B means A square minus B square. So sin square A minus B square is cos square A. Now we need cos square, isn't it? So let's convert this sin square to cos square form. 2 sin A is already in the numerator, and in the denominator let's convert the sin square A in the cos square form. Sin square A means 1 minus cos square a, isn't it? Because sin square a plus cos square a gives 1. So sin square a means 1 minus cos square a. This minus cos square a comes here. Okay, let me continue here. So in the numerator we have 2 sin a, and in the denominator we have 1, this one, minus cos square a and minus cos square a, same number, same sign, isn't it? So minus 2 cos square a. Okay, so this is what we have in the right hand side, hence proved. RHS. Okay, I hope you got this. Now let's move on to the next question, question number 45. Okay, now let us do question number 45. We have sin a plus cos a upon sin a minus cos a plus sin a minus cos a upon sin a plus cos a in the left hand side, and we are asked to prove this equals to this, isn't it? So LHS equals to sin a plus cos a upon sin a minus cos a plus sin a minus cos a whole upon sin a plus cos a. This is what we have in the left hand side, isn't it? So let us take the LCM of the denominators. These two numbers are totally different because they have different signs in between them. So the LCM will be the product of these two numbers, isn't it? Sin a minus cos a into sin a plus cos a. Okay, so the LCM will be the product of these two numbers. So sin a minus cos a into sin a plus cos a gives this whole thing. This means sin a plus cos a into sin a plus cos a, isn't it? So sin a, this is a, okay, sin a plus cos a whole square. This multiplies with this. Sin a plus cos a into sin a plus cos a is sin a plus cos a whole square. Plus this multiplies again, because this into this gives this whole thing. So cos sin a minus cos a into sin a minus cos a is sin a minus cos a whole square. Now a plus b whole square, we can see the formula sin a plus cos a whole square means a plus b whole square, isn't it? So a square plus 2ab plus b square. Are you getting me? A plus b whole square means a square plus 2ab plus b square, plus this plus comes here. Now sin a minus cos a whole square means a square minus 2ab plus b square, isn't it? So in the denominator we have a minus b into a plus b, isn't it? Sin a minus cos a means a minus b into a plus b. This means a square minus b square, a square minus b square. Now we have plus 2 sin a cos a and minus 2 sin a cos a, the same number, opposite sign, we can cancel these two numbers. So sin square a plus cos square a means 1, isn't it? Plus these two numbers, sin square a plus cos square a means 1. Again we have sin square a plus cos square a, this 2, again plus 1, whole upon this sin square a, we need cos square, oh, sin square a, isn't it? So this cos square a should be converted into sin square a form. Okay, so sin square a we write as it is, this minus comes here. Cos square a means 1 minus sin square a, because sin square a plus cos square a is 1. So cos square a means 1 minus sin square a. Okay, now let me continue here. 1 plus 1 is 2, isn't it? So this is sin square a. Minus into plus is minus 1. Minus into minus is plus. Minus into minus is plus sin square a. Let me do here. So in the numerator we have 2. Okay, let me write properly. 2 in the numerator we have 2, and in the denominator we have plus sin square a plus sin square a, that is 2 sin square a plus sin square a plus sin square a is 2 sin square a, isn't it? So this minus 1 comes here, minus 1. So this is what we have in the right hand side. Okay, 2 upon 2 sin square a minus 1 equals to RHS. Hence proved. Now let's do question number 46. Okay, number 46, we have cot a plus cosec a minus 1 upon cot a minus cosec a plus 1 in the left hand side, and we are asked to prove this equals to 1 plus cos a upon sin a, isn't it? So LHS equals to cot a plus cosec a minus 1 whole upon cot a minus cosec a plus 1. This is what we have in the left hand side. So we are asked to prove this equals to this, isn't it? So let's write this one as cosec square a minus cot square a. Okay, since we know that formula, cosec square a minus cot square a equals to 1, isn't it? So cot a plus cosec a, we copy as it is. This is cot a and this is cosec a. Now this is minus, and within the bracket 1 means cosec square a minus cot square a. Cosec square a minus cot square a, isn't it? This 1 means cosec square a minus cot square a. Okay, so in the denominator we copy as it is, cot a minus cosec a plus 1. Now cot a, this cot a plus this cosec a minus into plus minus cosec square a. Oh, this is a square minus b square, isn't it? So we can apply the formula a square minus b square and take the common. Okay, a square minus b square means a plus b into a minus b. A minus b. Okay, this cot a is this cot a, plus cosec a is this cosec a, this is minus. Now cosec square a is a square and minus cot square a is b square. Okay, a square minus b square means a plus b into a minus b. Why did I do this? Just to take the common out. We have cot a plus cos a here, and we have cot a plus cosec a here. Okay, so cot a minus cosec a is in the denominator, plus 1. So you can see cot a plus cosec a, this cosec a plus cot a means cot a plus cosec a, same thing. 2 plus 3 and 3 plus 2, same thing. So cot a plus cosec a and cot a plus cosec a is taken common. Cot a plus cosec a is taken common, and within the bracket remains, so this number is taken out, so 1 remains here, isn't it? This number is taken out, so 1 minus this number remains, isn't it? Cosec a minus cot a, cosec a minus cot a. Okay, curly bracket closed. In the denominator we have cot a minus cosec a plus 1, cot a minus cosec a plus 1, isn't it? So let me continue here. Cot a plus cosec a we write as it is, cot a plus cosec a. Okay, this and bracket close, so we multiply with minus sign. Okay, 1, this 1 minus into plus, there is plus sign in front of cosec a, so minus into plus minus cosec a, isn't it? So again minus into minus, this is plus cot a. Okay, and in the denominator we have cot a minus cosec a plus 1, isn't it? Cot a minus cosec a plus 1, cot a minus cosec a plus 1. So these two numbers are same, isn't it? Plus 1, there is no sign, means the sign of this one is plus, so plus 1 plus 1. Cosec a is minus, cosec a is minus, cot A is plus and cot A is plus. So these two numbers are same thing. So let me cancel these two numbers. We have cot A plus cosec A left now. Cot A plus cosec A, isn't it? So cot A can be written as cos A upon sin A. Sin A plus this cosec A can be written as 1 upon sin A, isn't it? Cosec A is 1 upon sin A because sin and cosec are reciprocal of each other. So let's take the LCM of sin A. Sin A is taken as LCM. We have cos A in the numerator plus this 1. Sin A into 1 is sin A, that 1 into cos A is cos A, plus comes here. Sin A into 1 is sin A, that 1 into 1 is 1. So this is what we have in the right hand side, RHS. Hence proved. So this question is a little bit lengthy, isn't it? But not tricky, but lengthy. I hope you got this. Now let's move on to the next question, question number 47. Okay. When we have 1 plus sin A upon cosec A minus cot A minus 1 minus sin A upon cosec A plus cot A in the left hand side, and we are asked to prove this equals to 2 into 1 plus cot A, isn't it? So let's do this. LHS equals to. This question is also very easy, but a very lengthy, okay, boring one, isn't it? So let's take the LCM of, first let me copy LHS. LHS equals to, you must always make the habit of copying the LHS first, okay, because we need to do in that way in the examination. So 1 plus sin A upon cosec A minus cot A minus 1 minus sin A upon cosec A plus cot A. So this is what we have in the left hand side, isn't it? Now let us take the LCM of the denominator, cosec A minus cot A. So these two are entirely different numbers, so let's multiply them and take the LCM. Cosec A minus cot A into cosec A plus cot A, isn't it? So the LCM will be product of these two numbers because these two numbers are different, isn't it? So cosec A minus cot A into cosec A plus cot A gives us this whole thing. So cosec A plus cot A into 1 plus sin A, isn't it? So 1 plus sin A into cosec A plus cot A plus cot A. Okay. So now minus sign comes in between them. So cosec A plus cot A into cosec A minus cot A gives us this whole thing. So cosec A minus cot A into this, okay, 1 minus sin A into cosec A minus cot A. So this is cosec A minus cot A. Okay. Now let me start from here, okay, we need a lot of space now. So 1 into cosec A, I'm multiplying this with this, and again sin A with this and this, okay. So let's multiply with 1. 1 into cosec A is cosec A, plus into plus is plus, 1 into cot A is cot A. Now again I have to multiply with sin A, isn't it? So plus into plus is plus, sin A into cosec A is sin A cosec A, sin A into cosec A. Now plus into plus is plus, sin A into cot A is sin A cot A. This is plus sign, okay. Plus sin A into cot A is sin A cot A. Sin A into cot A. Minus, again we multiply this number with 1, after that with sin A, okay. So 1 into cosec A is cosec A, plus into minus is minus, 1 into cot A is cot A. Now I'll multiply with minus sin A. So minus into plus is minus, sin A into cosec A is sin A cosec A, cosec A. Now minus into minus is plus, sin A into cot A is sin A cot A, sin A cot A. okay, whole upon, in the denominator we have cosec A minus cot A, cosec A plus cot A. So this is A minus B into A plus B, isn't it? This means A square minus B square, cosec square A minus cot square A. So cosec A, let me write this, cosec A, okay, plus, where is A, plus this is cot A, cot A. Now sin A into cosec A is 1, okay, sin A equals to 1 upon cosec A because they are reciprocal of each other, isn't it? So sin A and cosec A cross multiplied here, sin A into cosec A gives us 1, isn't it? So sin A into cosec A is 1. So instead of this sin A into cosec A, I write this plus comes here, and sin A into cosec A is 1 plus sin A into cot A plus sin A into cot A, okay, minus this is cosec A. Oh, let me not put this bracket, okay, useless. So minus into plus is minus, minus into plus is minus, cosec A, minus into minus is plus, cot A, isn't it? So minus into minus is plus, sin A into cosec A is 1, sin A into cosec A is 1, again minus into plus is minus, sin A into cot A, sin A into cot A. Are you getting me? So in the denominator we have cosec square A minus cot square A, that is 1, isn't it? So this cosec A and this cosec A can be cancelled because this is minus and this is plus. So this plus sin A cot A and minus sin A cot A can also be cancelled. So we have 1 plus 1, 2 plus, let me write this. This is 1 and this is 1. So 2, again plus cot A is plus 2 cot A. Okay, are you getting me? This one and this one is 2 cot A plus cot A is 2 cot A. In the denominator we have 1, so we need not write that. Now this gives us 2 and 2 can be taken common. So here we have 1 plus cot A, okay, because 2 into 1 is 2 plus 2 into cot A is 2 cot A, isn't it? So this is what we have in the right hand side, equals to RHS. I hope you understood this. Very simple sum, but very lengthy, isn't it? Boring one. So let's do question number 48, okay? Let's do question number 48. This is the last question from this exercise, isn't it? So in the left hand side we have cos theta into cot theta upon 1 plus sin theta, and we are asked to prove this equals to cosec theta minus 1. So let's do this. LHS equals to cos theta dot cot theta upon 1 plus sin theta, isn't it? Now let's multiply this fraction by 1 minus sin theta in the numerator and in the denominator as well, okay? While doing this, the value of this expression does not change because this number and this number can be cancelled, isn't it? 1 minus sin theta and 1 minus sin theta can be cancelled. So in the numerator we have cos theta into cot theta into 1 minus sin theta. Are you getting me? Cos theta cot theta into 1 minus sin theta. Here we have into sin, so bracket means into. In the denominator we have a plus b into a minus b, that is a square minus b square, isn't it? A square means 1 square, 1 square means 1, so minus b square means sin square theta. So cos theta into cot theta 1 minus sin theta, we write the numerator as it is for the time being. So 1 minus sin square theta is actually cos square theta, isn't it? So here we have 1 cos theta and here we have 2 cos theta. Cos is cos theta into cos theta, isn't it? It gives us cos square theta. So this cos theta and 1 cos theta gets cancelled. So now let's do this. This is cot theta. Cot theta means cos theta by sin theta. So cos theta by sin theta. This cot theta means cos theta by sin theta. Again we have cos theta here in the denominator. This cos theta comes here, cos theta, and we have 1 minus sin theta, isn't it? So this cos theta and cos theta cancels out. So we have 1 minus sin theta upon sin theta, isn't it? 1 minus sin theta upon sin theta. 1 minus sin theta upon sin theta. So this is 1 upon sin theta minus sin theta upon sin theta, isn't it? Sin theta and sin theta, take the LCM, becomes sin theta. So 1 minus sin theta comes in the numerator. So 1 minus sin theta means cosec theta, because sin theta and cosec theta are the reciprocal of each other. So minus this sin theta and sin theta can be cancelled, so we have 1 here. So this is right hand side equals to RHS. Hence proved. I hope you got this. Please take the screenshot. Thank you so much for watching this video. I hope you like this. I hope you understood the concept, but you must practice yourself. Unless you practice, unless you work hard, you are not going to learn. Okay, so practice yourself, and if you get problem, if you face any difficulty while solving any problem, then you can watch the video. Okay, so I want you to understand the concept of the trigonometrical identities. Stay tuned, stay happy, stay blessed, and don't forget to like and subscribe the channel.